Hey everyone, in this video we're looking at the big ideas for section 7.2. So we're going to start off by looking at this. It says the mean and the standard deviation of a sampling distribution for a proportion. Now notice this is for a proportion. It's going to be a little bit different when we get to means. But what we found out is that the mean of a sampling distribution for a proportion, and this is the notation for it, is equal to the population proportion. Whatever the population proportion is, that's going to be the mean of our sampling distribution that estimates that particular proportion. The standard deviation for a sampling distribution for a proportion is found using this formula. The square root of p, which is our population proportion, which is equal to the mean of our sampling distribution. So p times 1 minus p divided by our sample size. You got to make sure that you take the square root of all of that. The other big idea that we have is this, that we need to check a couple of things. In order to check for normality, we have to check the large counts condition. If this sampling distribution that we are creating or trying to create is normal, or really I should say, we want the sampling distribution that we are trying to create to be normal in order for us to use it. But the only way to check to make sure that it's going to be normal is if the large counts condition is satisfied. So we have to check n times p and n times 1 minus p. If both of these give us a value that is greater than 10, in other words, more than 10 successes or 10 successes or more, or 10 failures or more, then what that tells us is our sample size is large enough and it makes sure that our sampling distribution will end up being normal. So finally, the last thing that we want to look at is this. And that is that the probability of the probability if the sampling distribution is approximately normal, we will use this formula. In other words, really need to say that in a better way. In order to find the probability if our sampling distribution is approximately normal by checking the large counts condition, we're going to use a z-score formula. And our z-score formula is this formula right here. We're going to take p hat minus p and divide by the standard deviation for our sampling distribution. And this follows our formula for z-scores already. If we remember, our formula for z-score is value minus the mean divided by the standard deviation. So this is the same thing. Our p hat is our value minus our mean, which we just established up here, is equal to p divided by the standard deviation. And the standard deviation for a sampling distribution for proportions is right up here. Square root of p times 1 minus p divided by n. So all of this should help us to create a normal distribution in order to find some type of probability or area under the curve. Hopefully this helps you understand sampling distributions for proportions a little bit better, and hopefully you have a great day.